Good evening and welcome back to Vegas October 1 Sounds. Tonight I'm going to present a few of the graphical results of what regular viewers will know as the box plot. And the box plot is a graphical technique for locating the source of a sound from multiple videos that have been synced from a visual cue. In the notes you'll find reference links to all the prerequisite material for coming up to speed on this video. But basically what happens is you take several videos which have a common visual reference point and you synchronize them all to that point. I use the marquee sign out in front of Mandalay Bay. And then having synchronized those videos, you locate a common sound to all of them, which you wish to determine who receives the sound in what order. Now this technique works very well for things like muzzle blasts, which have a single point source of origin, which is the end of the muzzle, and which propagate out in all directions evenly. Doesn't work at all for things like supersonic cracks, which don't follow those same physical rules. You could probably use this technique for people talking, isolating where they're coming from, and that sort of thing. But anyway, a long time ago, basically I showed that if you take, for example, this is a zoom in on the Raymond Page video, and here you can see the marquee sign, even though it's blurred out in front of Mandalay Bay where it's all black in the middle. And if I step forward one frame, you can see where it starts to turn blue, then it goes bluish, bluish, and bluish. And I can isolate that similar event in all of the videos that I make reference to tonight, and then I synchronize them. And then I take volley 9, and in particular burst 2. There's 3 bursts in volley 9. I'm going to take burst 2, it's the longest portion, and I'm going to take shot 1, and I'm going to find shot 1 in all of the videos, and I'll mark it, and then I'm going to measure the time difference between when the sign, that common visual event, turned and when the sound is heard. And from that I can establish in pseudo real time who received the sound first. And the end result of all that will be something that looks like this table down here called time of arrival of muzzle blasts. The raw information is presented right above there, where you can see which videos I'm using. Oasis is Oasis Apartments, Ray is Raymond Page, and I'll give you links in the description to all these. Across is just north of Cop Corner, where a fellow is standing on top of a little bitty trailer, well, kind of like a 10-foot high trailer, next to the VIP tent on the west side of the venue. Hebrew are the ladies that are speaking Hebrew. I think it's ladies. Anyway, they're in the Luxor parking lot area, and Excalibur is the top of the Excalibur Hotel up the strip north. 7 underbar 38 and Air 2 I'm not using this evening, so don't really come into play. And I'd like to give a shout out to the Las Vegas shooting map, because I use it every day, and without it I'd have a lot of work to do myself to recreate the efforts there. Once you have this information up here, which basically says that we're sharing this common event, which I call visual event, called 9 underbar mid, and in these videos, that event starts at this time relative to the start of video and ends there, and has a duration of this. Now, as you can see, there's some discrepancy as to the duration of the event, and I choose to make reference to the last portion of the event, which has a much quicker transition time. It goes from dark to light in 1 frame. And then I describe the audio event that I'm isolating, which is the first shot of volley 9B, and then I record the time in the audio in which that occurs, and from that I can calculate the gap between the audio and this end event, record it there, and then you can sort them based upon the gap. Now, because of the location of the audio to the visual event, the times are in just exactly the opposite order here, where the smallest number is the furthest distance. But the end result is this time of arrival muzzle blast table. And the way you read this is, if we have a sound that arrives at the Oasis Motel and read down this column, then we can say for the Raymond Page audio, it arrived 0.321 seconds earlier because it's negative. It arrived at the Excalibur 0.3 seconds later because it's positive. And so we can take all these numbers, and as you can see, it's symmetrical about that diagonal there, which is blank. And then what we can do is create a plot. And this is what I call the box plot. So what I've plotted on this map is the latitude on the left column and longitude on the x-axis down here at the bottom. And those numbers are taken straight out of, Google Maps. Let's see. Yeah, over here is an example where I locate the real location of those Hebrew ladies. Las Vegas Shooting Archive has them over here, but it's actually much, much closer to the entrance to the Luxor Hotel. And you just take this number right up there, and that'll be the location and latitude and longitude. All right. So back to our little box plot. So anyway, what I demonstrated, and then there's 3 videos in that I make reference to, which have gone into this in detail, just not in a formal graphic way. I did it all by hand, and it's kind of sloppy. So what I've done is, on this latitude and longitude plotted the 5 videos that I'm going to make reference to this evening: Excalibur, Raymond Page, Hebrew, Acrost, and Oasis. And then I've also plotted the locations of rooms 32135 and room 32134. Now, the general theory of this is that if we take the distance between any 2 points, in this case I've chosen Oasis and Excalibur, and divide it equally in 2, then that would represent the point at which the sound difference between time of arrival between them should theoretically be 0 if it occurs along this line. So if the time is closer to Excalibur, then the source of the sound should be up in this white area, and if it's closer to Oasis, then it should be down here in this lower region. So we can go back over to our table and say, in this case we're using Oasis and Excalibur. And we say if we're at the Oasis, then the Excalibur arrived 0.37 seconds later. In other words, the Oasis arrived before, the sound arrived at Oasis before it arrived at Excalibur, and therefore on this plot the darkened region is the one where the source of the sound would naturally have to occur. Now this is a 2D projection of a 3D phenomena, because these things, the shooting location can have elevation, but it still works out. This is an actual projection, not a representation. So we can take and apply this same technique to a different set of points. So let's go over to here and select a different set of points. And I have these numbered here. In this case, I chose the Hebrew and Oasis. So once again, we plot a line between them, divide it in 2, and this sort of semi-dark line represents that point, and then we have to go over to our table and look up which came first, Hebrew or Oasis, in terms of sound of arrival. So we go over to Hebrew, look down, Oasis came after, therefore Hebrew came first. Alright, so then we plop back down to our graph over here, and since Hebrew came first, we notice that we mark all the things up here as being potential locations for the shooter. Now you say, well, wait a minute, on the previous one they were marked down here, and on this one they're marked up there. The shooter can't be in the same place at the same time, and that's correct. But if we overlay the 2, then we get the region that is common. Oops. And that region will look like this. from those two things, we see that the region which overlaps has refined the potential regions for the shooter. That is, where the shooter may be located, or where the source of the sound is the overlapping region, which I'll just draw it here on a crude thing. Now this thing would extend out to, a long ways over there, but that's kind of irrelevant, and I drew it very, very sloppy, but I just wanted to, highlight the region. Okay, so that's with 2 points. And we can continue to do that for other points. And it's important to choose these points carefully, because a lot of the combinations of points are going to be redundant. That is, they don't refine the point anymore. They just sort of clutter the graph. So in this graph, we have the overlap of the two. We have the Oasis to Excalibur, this darkish green line here, which we call the normal. Same thing over here with the Hebrew to Oasis, the reddish line being the normal, and then which side of the graph they were on from that earlier table in over there in my Jupyter notebook work laboratory. So from this you can see that indeed room 32-135 and room 32-134 were in the potential region of where the source of the sound is located. However, there's also of quite a few other regions. What we have noticed is that we've eliminated a vast portion of the venue and any other places like east of the venue or directly west of the venue of the Luxor Hotel were not, from this graph, potential sources for that shot. And as I've mentioned before, once you isolate a shot in the volley down, you've isolated the whole volley in terms of the source of the sound, because we can take the actual times of arrival of all of the muzzle blasts, and since they're preserved across distance from source to source, that would imply that the shooter is static, and therefore we can make a lot of assumption and make these assertions that once we have one bullet isolated in a volley, then the probability of all the other bullets being shot from the same source goes way up, particularly if we have multiple videos which show the exact same timing for all of the muzzle blasts. Because if we had another location, then the timing would be different in some manner. The time of arrivals would be different. And what we're measuring here is absolute times of arrival. Alright, so that's for two overlapping pairs. So let's take a look then at another choice for the next pair. And I've already marked the ones that I want here. So we were at 3, so I'll go over here to 4. This is the next pair that I choose. And this pair is the Raymond Page and the Hebrew. And once again, we draw this distance between the two, and we draw a normal line, i.e. the line perpendicular to that, and then we figure out which location received the sound first, and then we color it. So once again, we plop back over to our table, and we were looking at Hebrew and Raymond Page. So Hebrew and Ray. The Ray came after the Hebrew, therefore, because it's positive here, so the Hebrew is first. Okay, so back over to our little thing, and the Hebrew's first, so we mark that side of it. And then we have to overlay that on top of that existing set of the other two pairs to further refine this region down there. So let's go ahead and find that graph. Okay, this is the graph. And here again you can see that we have 3 different regions colored. We have the green one, we have this red one, and we have the purple one. And the overlapping area then defines the region in which the source of the sound could potentially be located. Now in this one, you'll see that the area in question is bounded by this purple line. bounded by the red line, bounded by the green line. And then we really don't know how far down there it's bounded. Again, we're still including room 32-135 and room 32-134. Now what we'd like to do is choose a point which is going to limit this lower bound or limit this leftmost bound in some way. So then the next choice I would make is something that might limit that. Although we could just, plot them all on there and try to make sense of a very cluttered situation. So I chose, let's see, I have number 6 in here located. I chose this pair. I chose the acrost and the Hebrew ladies. So once again, we'll plop over to, we draw the line between them, draw the normal, which is the perpendicular, plop over to our table, and we are asking about across and Hebrew. So Hebrew to across, the across came first because it's negative. Plop back over to our thing. Hebrew came first, draw the upper region. Well, now we're going to have a little bit of a problem here, but it does limit things. So then let's go ahead and lay that on top of all of our other graphs, or other exclusion zones. See, 6, I want number 7, there we go. 7, and this is the picture that we end up with. So, in this particular scenario, let's see, I think yellow will do the good job. We are bounded by the red line. We are bounded by this new one, Hebrew and Ray, the blue line. Comes down. We're bounded by the purple. And then we're bound by this green, which cuts it pretty close there. And so we could continue to do that until we have the smallest region possible. The problem comes in that to cut off, let's choose another color. To further reduce this, we'd have to have that normal be something like that or something like that, let's just say. So we'd have to have an oasis and maybe a point over here somewhere that would do the job. So I'd have to go looking for a video over there which I could sync to these that the sound arrived at first, and then I could cut these things off. Now if you'll notice here, how close have we narrowed this down? Well, it still is pretty big, considering that we'd like to know within a few feet, but this technique doesn't really lend itself to giving really defined regions, but it does quickly eliminate things where it can't be. And as you can see, there's that. Well, anything outside of this region has been eliminated. This region has been eliminated. So we could overlay a map of Mandalay Bay, and we could see here that since it's probably, let's see, what was it about? Let's draw it in blue. Something about like, I think like this. This kind of rough. Something about like that. You would see that pretty much anywhere in the Mandalay Bay region would be a viable candidate until we further refine it. So this is the box plot, and this technique it can be done by hand. It can be done without any complex math, but it does require very fine and detailed work. You have to locate the videos, you have to synchronize them, you have to locate the sound, and for some people that's kind of difficult. You have to locate a sound that's common to them all, measure them, and then do the calculations that I would to create that table. Although you don't really have to do this, all you have to do is observe which sound came first, or which location recorded the sound first, and then you could do these nice little plots. Now, this thing took me, conceptually this is a straightforward, almost trivial process to create these graphs, but because all you have to do is draw a line between the 2 points in question, draw the normal, which is the perpendicular, and then draw a series of parallel lines in the direction to the point which received the sound first. And all of that is fairly straightforward. But the actual implementation turned out to be a brute. It's not long, but just getting everything square, getting the colors right, getting the how far apart these things should be drawn right. That took a lot of trial and error for me. But here it is. It's not fully automated. I can't just apply it to any random synchronization, but I will eventually. Alright. Let's see if there's anything I forgot this evening. No. So anyway, for those that asked, this is a box plot of volley 9, narrowing identifying the source of the sounds for muzzle blasts as the region commonly known as the Mandalay Bay. Now I don't identify elevation here, but with those numbers I presented you could through various calculations. So, anywhere from ground elevation to some 1,000 feet in the air or whatever's ridiculous could be potential candidates there. So it's still a pretty large area. But we have eliminated the Luxor or the Tropicana, helicopters anywhere but on top of the Mandalay Bay, essentially. Okay, well, that is what it is. So, where am I going from here? I've got two things immediately on my plate. In the next 2 days, I'll be doing a comprehensive review of Volley 9 from at least 10 or 12 videos. And the purpose of that video will be to address a question that was raised by Brian Shields. And the question is, we have 3 videos, all of which contain the same region and time, and yet the sounds are different. And the question he asks is, do those 3 videos demonstrate that there's a sniper in the venue? And so to answer that question, I'm going to take 2 different approaches, and I'm going to review lots and lots of audio from Volley 9 and show you why I believe that the woman who was shown in the Brian Shields videos going down was most likely hit from just a round from Volley 9, probably the second burst of Volley 9. Nailing down which sound exactly caused the hit the girl is very, very hard, because the mathematics of calculating the bullet speed when it hit her versus when the sounds arrived from the positions that you're at, that's, and it's probably not stuff that people really want to look at, and it's not trivial, so it's really prone to error. But we can make general statements and say that it was likely she was hit with just one of the rounds that was fired in the second burst of Volley 9, which in and of itself I think is a pretty big statement. And then after that, I'm going to take this box plot and substitute in a parabolic plot, which is very, very similar to what the Vera people did in, let's see, was it method 1 or method, I forget which method, I covered it earlier in terms of which method, where they use, rather than box plots, we'll use parabolic equations to further refine the location of the source of the sound. So between the parabolic plots and the box plots, there probably would be very little doubt as to the source of the sounds, at least for the volleyers or shots that you apply the algorithm to. So anyway, that's it for this evening. We'll grab you in the next one.